Hello YouTube, I just thought I'd share something with you guys. I did a math problem the other day and I'm like, oh my gosh, this problem in multivariable calc help make everything make sense. Get it? Okay. That's a sense sign if you guys didn't figure it out. So I was doing this problem, I'm like, oh, I understand now. Okay, so I just thought I'd share it with you. This is specific for 3D graphing though. And how you can formulate a 3D graph without knowing exactly what the function's graph looks like, obviously. Okay, so here's the function we're given here. And first, just basic stuff before we get into the amazing part. You should recognize that this is a circle, and this whole component would make a sphere then in multivariable calc. So we're going to find the x-intercepts, y-intercepts, and the z-intercepts first. Okay, so you know that the intercepts are, you know that the equation is x squared plus y squared equals r squared for a circle. So for a sphere, the radius is also r. So if that's r squared, if 25 is r squared, then to find out what r is, you take the square root, plus or minus, right? So the radius is plus or minus 5. So that means all the intercepts for the axes are at the 5 mark, I guess you could say, on the axis. So that means the x-intercepts are plus or minus 5, so x is negative 5, x is positive 5, and the rest are 0. The y-intercepts would be at the positive and negative 5 area, and for the z-axis it would be at the positive and negative area for the 5 as well, so plus or minus 5. So I'll just plot those points real quick. Okay, so I drew the whole thing. Here's the y-intercept, here's the other y-intercept, here's the z-intercept, here's the other z-intercept, here's the x-intercept, and back there is the other x-intercept. Okay, so pretty much you know that it's a sphere, obviously, because of the formula you should be aware of. So I originally have the circle shown here on the xy plane, but then since it's three-dimensional, you make it into a sphere. Okay, so what if you didn't know it was a sphere, in other words? What you'd have to do is sketch the traces, and traces are pretty much show slices or portions of the graph. And this example asks to find the trace in the xy plane, y equals 3, and z equals 4. So we're going to do that. Okay, so the xy plane, again, emphasizing that this is a slice of the 3D graph. Okay, so we have the xy plane, so that means we'd have to have z equal 0 in order to have just the xy plane. So to do that, we would just make z equals 0 from this here, so we just make this go to 0, and we'd have x squared plus y squared equals 25. Same thing, you should know that the radius is still 5. So, because the square root of 25 is 5. So our circle would look something like this. Boom. And all these area, that's a 5, that's a 5, that's a negative 5, and that's a negative 5. So that's the xy plane. Remember, just to recap, we made z equal to 0 to figure out the plane. So this is the first slice of the graph. Okay, next slice. Y equals 3. So for this one, we're going to have, just plug it into the, so plug, whenever you see a y, you plug 3 in. So we have x squared plus 3 squared, which was y, plus z squared equals 25. So this is just at one area of the graph. And we'll figure out that x squared plus z squared equals 16. So the radius is 4 this time. Okay, so at this portion of the graph of the sphere, the radius is 4. Alright, and same kind of structure for writing, for knowing it's a circle as well, so you could graph it as a circle. And you get this. So now you have this area, remember the radius is 4, and then you just have another complete circle. So this is another slice of the graph here. Okay, so now we're going to do another slice. So z equals 4. So now you just, wherever you see the z in the original problem, which was x squared plus y squared plus z squared equals 25, you plug in a 4. So you'd have x squared, oops, let me do it in brown, x squared plus y squared plus 4 squared equals 25, and that would simplify to x squared plus y squared equals 9. Okay, so same thing. Hey, look, it's a circle again. So that means the radius for this time, or for this portion, would be the square root of 9, which is 3. So the radius is 3. So now let's draw the circle, and you should get that. Okay, so simple enough. We drew 3 circles pretty much, but what do all these circles mean? This one has a radius of 5, this one has a radius of 4, this one has a radius of 3. So, well, let's put all the slices or the pieces together on the final 3D graph. Okay, here we go. Because we already know this is a sphere, I'm going to draw the sphere out, but I want to show you where all the pieces come from, and that's why this problem made sense to me. Okay, so I'm just going to draw the sphere out, so here's just the basic outline portion. Okay, so now we're going to look at this part first, the xy plane. So the radius was 5, okay, on the xy plane. Where's the xy plane here? Okay, here's the y, here's x, okay, xy. So we're going to tilt this circle on its side. So that means the radius is 5. Oh, let me do it like this so you get more depth. Do you see what I just did there? You should be like, oh my gosh, it's making sense, sort of. Look, this is 5. 5 back there. Or 5 actually back there. It doesn't matter, actually 5 everywhere. -5. You get the point. This circle, we turned on its side. So this circle is no longer looking like this. You flattened it out on the graph like that. Yeah. So that's where that portion came from. When everything's color-coded, you'll see where it makes sense in a second. Okay, so remember that was the radius, that was 5. Okay, so now we're going to do this part. Where the radius was 3, and that was on, okay, so y equals 3. So that means this portion would be here. Here, I'm going to label some stuff here to make sense. Okay, so we have the y equals 3 graph here, and that's on shown here, so that means we'll have a circle going like this, and that region is the y equals 3 trace. Here, I'm going to try to make that look more like it's going in. It's kind of hard to get that depth. But there's that portion. Okay, so that's the second slice. We had the first slice was the green, second slice the blue. Let's go to the third slice here. Okay, so now we have z equals 4 trace. Okay, so this is the last slice. So z equals 4. Oh, z equals 4. Okay, so that means, oh, what was the radius? 3. All right. We'll draw the radius out to 3. It's about there. There you go. And depth, trying my best. Check it out. Look, you got the boundaries of all these points here, and you're figuring out if you made an infinite amount of traces, like boom, trace, 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 that direction, and traces all the way this way, you could fill out the entire graph with traces. But now that you got the general idea, oh, okay, so it's a circular area vertically and horizontally, and the radius increases to a certain point where the radius is 5 at its max, as you could tell by the xy plane. Therefore, you can conclude that it's a sphere with a radius of 5. Isn't that awesome? You did all the slices, and you figured out what the graph looks like, even if you didn't know what this looked like in the first place. So, the reason I chose a familiar graph is so you have more of an understanding. Now you can make all these traces or slices of a 3D graph and figure out what your end result is going to look like. It's just amazing, and this problem made sense, and I hope it made sense to you guys. Good luck practicing your 3D graphing and trying to figure out what all these functions you're given really have to do with their domain, their range, when to calculate their slopes at a certain point, mapping, whatever. So this will be your foundation for multivariable calc in terms of how to visualize how things are. And I did my best to show the visuals, but now you got to do it your part and keep practicing. So hope this helped a lot. It really helped me.